Biology is going through big changes in the ways that we learn things and the opportunities that we have to learn across a spectrum we never imagined before. But the way that we do our research, stable, non-dynamic, one individual at a time, doesn't adapt well to the opportunities that we have in front of us. Are there different ways of doing it where we can really adapt and use in real time a broad spectrum of expertise, people's imaginations, open up people's imaginations?
People have a number of different ways in which they design things or think of things that, like, what if this was something that was in the world? How do we make this a user-centered process going forward? So in the sciences, there's all these issues of either making something that nobody ever wants or hitting dead ends with their hypotheses. Is there a rough process that they can learn about that might inform and change how they pursue those scientific questions?
My name is Reed Williams, and I'm a graduate student here at UCSF in the biophysics program. And so I've been working over the past month in August on a project to help out a researcher, Dan Fletcher at Berkeley, with an object that he's created called the cell scope, to try to get a better sense for what scenarios the cell scope might be useful in. We talked to a number of people to get both inspiration and perhaps insight into what it is they do and how cell scope might be useful. One really great thing that came out of this is that the 7th grade teacher told us that her goal is to demystify technology. She wants her students to be able to take apart the scope itself, see how it works. She was really excited by the idea of a scope that could be disassembled and reassembled by her students.
This is a microscope that's made, the framework and all the physical positioning of everything is made out of Lego blocks with specific adapters that are 3D printed to fit optical components like objectives, filters, and lenses. What the students would do is that they would build the frame and everything out of Lego blocks, and the optical components would, because they've been Lego-fied with our 3D printed adapters, can easily snap in and out.
The best work in the future is going to be done by teams of people that come together that have very different expertise, that know different things, that think about things in different ways, that then choose to come together to focus on one big problem. I think that we've learned that this is an experiment that's worth extending into the ways that we do our normal research.